Okay, let's go and get started today. Today is going to be a relatively short lecture because it's a new lab, and I want to give you time to work on finishing up the previous lab, Lab 1, or working on Lab 2. But I'm going to spend a little time talking about this and doing a little bit of stuff to kind of get you started here. And so let's go ahead and get started with where we are. And essentially, Lab 2 is going to be doing some particle effect stuff, and there's also going to be some stuff with objects and inheritance. So for this lab, you're going to be implementing a variety of particle effects. Inheritance is going to help you with that task, so you don't have to rewrite all of the code over for each kind of particle. So let's go ahead and take a quick look at the lab assignment sheet. So give me a second to switch over to that. Okay, so here's the lab sheet. Essentially, assignment 2, particle effects. So the lab concept here, what you're going to be doing is you're going to be creating particle effects for snow, smoke trails, fireworks bursts, and snow. Why did it say snow twice? That should say smoke. No, smoke, fireworks burst. Oh, the rockets themselves are going to be particle effects. So basically, you're going to be creating this kind of New Year's Eve fireworks show, or whatever you want to think of it as, I guess, given the due date, Valentine's Day fireworks show. But snow will fall from the top of the screen because it's winter time. It'll drift down towards the bottom of the screen. Rockets will launch from the bottom of the screen in upward direction. As rockets fly, they'll leave behind like a smoke trail. And once they burst, the rockets will disappear and they'll be replaced by a burst of like colorful fireworks particles, or whatever you want to think of it as. So the different particle types will be created using some object-oriented programming with a little bit of inheritance. And the idea there is that we're going to create this kind of generic particle class, and then we're going to inherit from that with the other ones. So this gives us the details of that. I'm not going to read over all of this, but the idea should be pretty straightforward. But lifetime represents the age of the particle when it should expire. The age, so this is a little bit different than what we did in our example last time. Age is how long the particle's been in existence. And one of the things that I want to do here that's a little bit different about what we did last time is this allows us to set the age not in number or the lifetime, rather than have it count down or be a number of frames and have it count backwards to 0 and then disappear when it gets to 0. This is going to allow us to have an age start at 0 and have it count upwards. And when it gets to the lifetime, then it expires. And there's an advantage to doing it that way and making it based on the actual time, in that we can then use in our main program kind of a dt, or a delta t, for how long each frame took. And we can base the particle's existence on a number of seconds rather than just some arbitrary number of frames. And if we do that, then we can make a game that even as things get complicated, or the time per frame takes longer and longer, we can still have it so it behaves the same way. And that can be really important to a game, that under load or on a slow processor, the particles still stay around the same amount of time. They still do the same kinds of things rather than having it be really time dependent. And we're going to do that in our example here. All right, so in the generic particle methods, it basically has an init that sets the starting conditions, an update like we did before, a render like we did before. And then we're also going to create this particle system object, which is a generic particle system object, which basically is going to have a list that holds all of the particles that we create. Init, which is going to create one of the particles. Emit particle, which is going to create a new particle at a particular place and at a particular, in this case, particular location and of a particular style. We'll talk about that later. Update particles goes through all of the ones in the list and updates all of them. Render the particles goes through all of them in the list and renders all of them. Now, essentially what you're going to have is these derived classes that are built off of that, of the generic one. So smoke particle, notice it says it'll be gray in color and should be used to represent the smoke trail of rockets. The smoke particle should fade to black and expand throughout the particle lifetime. So in other words, as they move, they're going to get larger and maybe more transparent too, if you want to do that. We looked at doing that last time. But they should fade towards black as they continue their existence. Burst particles should be brightly colored bursts of colors. They should be used to represent firework bursts. Colors should change and eventually fade to black throughout the particle lifetime. Now, we can talk about ways to get these to fade a little bit differently later, but notice it doesn't say anything about the size changing. In other words, these are like bright little sparks, and they will just fly and then eventually fade to black and disappear. Rocket particles, rocket particle system, those should be colored neutrally, so not necessarily like gray, but maybe like a brown, like a little shell. But those are going to fly up like a little rocket, and those will eventually, when they reach, or after a certain amount of time after they expire, they'll disappear. They'll be replaced with one of these burst particle systems. And then the snow particles, those are going to be colored white. They'll be slightly transparent. They should drift from the top of the screen down towards the bottom with a little bit of randomness in the motion. So as the snow falls down, it should kind of, just like you drop a paper on there and it kind of slowly floats toward the ground. A little bit of randomness in that kind of side-to-side motion. And then the main program, basically it has some stuff here. The snow particles fall from the top of the screen towards the bottom. When the space bar is pressed, we launch a rocket from a randomly chosen location along the bottom in an upward direction. The rockets will leave behind a smoke trail as they travel. And the rockets, when they disappear, they'll be replaced by an explosion of burst particles in that kind of upper quadrant of the screen when the rockets disappear. And when the escape key is pressed, the program should end. So what you should have, program will run, snow will fall, you press the space bar, rockets fly up. When the rockets disappear, you get a fireworks burst. And as the rockets fly, they leave smoke behind. Now, as a quick overview here of how, I want to do a little bit of an update on how do you do this age and lifetime thing. So I'm going to switch over to a Python shell really quickly and just program that part of it. I don't want to do the whole lab for you, do too much of it, because I want you to go through the work of doing that. But let me go ahead and bring up a Python window here and make a new window. Let me size that so you can see what I'm doing. Okay. Okay, now let's go ahead and write a little bit of code here just to get you started. So let's import Pygame, import random, import math, and let's also import pygame.gfxdraw, which, remember, that gives us the ability to make shapes that have transparent properties to them. And let's go ahead and do our normal code here. So let's go ahead and pygame.init. Let's make a display surface. Or set mode 800 by 600. Oh, you can't. Can you see what I'm doing? Yeah, okay, good. Okay, now let's make our main loop here, our game loop. So while true, I will say pygame.event.pump, and I will do pygame.key.get pressed, and I'm going to store that off just like we've done before. Keys equal. I'm going to say if keys pygame.k underscore escape. Break out of the event loop. Eventually at the bottom of the event loop, we're going to need to do a pygame.display.update. We're probably going to want to clear the screen before we write to it. So ds.fail 000. And then after we're done with that main loop, we're probably going to want to do a pygame.display.quit to close the window down. And we probably want to control the frame rate here as well. So here's one thing I'm going to do. I'm going to say frame rate equal. I'm going to set this to 120, but I'm also going to have a variable dt, which is my delta time. And I'm going to set that to 1 divided by frame rate. And that's going to give us the ability later on in the code to basically use this dt to count how long that particle, a particle has been in existence, and base the lifetime of that particle on a certain number of seconds of existence rather than something else. Now, down here, let's go ahead and make our clock. So let's do a FPS clock equal pygame.time.clock. And then let's at the top of the loop do FPS clock.tick frame rate, frame underscore rate. Okay, let's go and run that and see that that actually all comes out and works okay. Let's call this particles dt.py. And there's the code right now. We're not drawing anything. Brings up the code. We hit escape. It closes it. All right, now let's go ahead and add some code now to make some simple particles. And what I'm going to do here is I'm going to go ahead and kind of do what we did last time, but I'm going to kind of make it like what you need to do for your lab. But I don't want to do too much of the work. So I'm going to only do kind of a minimum set here. So generic particle. So there's a generic particle class, and we know that that's going to need a constructor. And according to the, if you look at the lab sheet, we know all the things that the constructor needs to have in it. So I'm just going to go ahead and, actually I'm just going to go ahead and copy those off of the lab sheet into here. And I've got to fix this up here. And I apologize, the font is such that I can't fit all that in one line here. I could probably make it a little easier to read by splitting this line. Let's do that. Okay, so now we know all of those things we need. So we just need to make self.x equal start x, self.y equal start y, self.direction. And that's the same as our angle that we used last time, equal start direction. And really, if I were writing this code, I'd probably leave the start off on each of these things here. But that's just showing that's just the initial parameter for the, or value for that. Self.speed equal start speed. Self dot, what else do we have here? Lifetime equal start lifetime. Self dot size equal start size. And self dot color equal start color. Now you'll notice there was one thing that's on the list of things from the lab sheet that's not here, and that's that age. So I'm going to go and put that, and I'll put it on the same position up here right before the lifetime. So it's going to be self.age. And the age, when this thing gets created, is going to start at 0. We don't pass in its starting age. It always gets born, it starts at 0, and it's going to accumulate the age as it exists and gets updated, and eventually we get to the point where we get rid of it. So now down here, in our code down here, this is going to be for update. We're going to need to fill in the code for that. And we're also going to need to fill in the code for render. Okay, so for update, if you remember what that needs to do, that just basically needs to say, hey, if the particle still has life left, then we need to kind of continue to propagate it and move it at the current speed and direction, and then update the particle lifetime or the age to see if it's if essentially as it continues, we need to add that age. So what I'm going to do here is I'm going to basically say something like this. I'm going to say if the age is less than or equal to self.lifetime, I guess I need self.age too, don't I? If self.age is less than or equal to self.lifetime, then that means we want to do something with this particle. What do we want to do? Well, let's first age it. Let's say self.age plus equal, and I'm just going to put dt here. So we're going to age it by that dt amount. And if that's the case, that it's less than or equal to that, then we want to go ahead and move it. So to move it, we're going to calculate the dx, and that's going to be, let's see here. Let's do dt times self.speed, and I'll explain why that dt times that is there in a second. Self.speed times math dot, now this is dx, this is left and right, so this is cosine, math.radians of self.direction. Now, why do I have dt there? We haven't seen that before. The reason dt is there is that's going to allow us to set the speed in pixels per second rather than just have it be some number of pixels that gets moved when we multiply it by that thing. So this dt, putting dt here, means that we can specify the speed in pixels per second. And because that dt is 1 over 120, that means that this will get called 120 times. So if we have the speed of 1 over, and multiply that times 1 over 120, we get 120th of a pixel per thing. So if I set it to a speed of 1, I'll get 1 pixel per second. If I set it 10, I'll get 10 pixels per second. So this gives us the ability to set the speed in something that's more understandable and more reasonable. So let's also compute the dy. Same thing here, except this is sine. And remember, we need to multiply this whole thing by -1 because of the inverted axis. So that moves the particle to its next position. And really, that's probably all we need to do here. If we wanted to, we could add bouncing and the other things. But for right now, that's all I'm going to do for update. It just updates the position based on the speed and direction that it's traveling. Now, last thing we need to do in this is actually update the position. So self.x plus equal dx, self.y plus equal dy. And now for render, I'm going to basically just do a GFX draw. So pygame.gfx draw onto the display surface. And if you remember how this works, we pass in the parameters for GFX draw were a little bit different than the parameters for the normal drawing of a circle. So if you remember how that works, let me pull that up real quick to remind you. Okay, so here's the website for that, for GFX draw. Just Google Pygame GFX draw. And the one we're going to want to do is a circle. So if you click on that, remember how it works is we want this filled circle. And filled circle takes the surface, an X, a Y, a radius, and then the color. So the things are in a different order than we're used to. And the X and Y are separate things. But it's always the surface first, X, Y, radius, color. All right, so let's go back to our code. So GFX draw, surface first, or we need to do dot filled circle. So surface first, and then X, which is going to be self.x, self.y is next, radius, self.size we're going to use for that, and then color. And there's our code for making that filled circle. Okay, so far, so good. One thing we might want to do is on the self.x, I don't know if filled circle requires it or not, but we maybe want to wrap those in int calls because the locations are only integers, and probably the size. There's not fractional radiuses, so We'll put an int around that as well. Okay, so there's that. And now let's go ahead and make our generic particle emitter as well. And that generic particle or generic particle system. So let's make a class for that. And if you remember the idea behind this, is really this is just going to keep track of our lists. So we're going to have self.particle list. And that list is going to start out with no particles in it. But then what we're going to have down here is we're going to have an emit particle. And that's going to have a start X and a start Y. So here, how do we emit a particle? Well, to emit a particle, it's going to be relatively easy. We just want to add one of those particles to a list. So here, I'm just going to say self.particle list.append. A generic particle. At that start X and start Y position. Now, note when you make a generic particle though, there's a lot more we need to specify. Start direction, start speed, start lifetime, start size, start color. So what I'm going to do now is go ahead and add the other things that I want to add into here. But rather than put them in, I'm going to go ahead and basically just, I'll set these individually before we make a call to this. All right, so we need an initial direction. I'm going to just set that to be any direction. So random int 0 to 359. Oops. Let me fix that. That guy. And then we need a speed. And let's make this from, I don't know, 10 pixels per second to 30 pixels per second. So that'll handle the speed. And now let's do the lifetime. Oop, we already had that. Start lifetime equal. Let's make them exist for 1 second. Let's make the size right now equal to, let's just do 4. And let's set the color equal to just white right now. All right, so now we have all the things that we need to emit that particle, and it gets added to the list. And so now the other parts of this are relatively easy. Update particles. So def update particles. That just needs to go through and say for particle in self.particle list. Update them. Or particle.update. And give me just a second here. I'm going to pause the video. I'll be right back. Okay. I apologize for the little delay there. There's a dog outside barking, and now there's dog heavy breathing activity going on. Hello. I don't know if you can see that. There's a dog. Anyway, let's finish up this code real quick. where were we here? We were on finishing the particle update, and then we're also going to do the render, which, if you remember what that looked like, that was essentially a render particles method. And that basically needs to do the same thing that we did with the update, but we're just going to go through and render all of them. So we go through all of them in the particle list, but rather than doing an update, we're going to do render here. Okay, so there's our basic classes. Now there is one thing that we probably need to add, and that is, notice that we haven't actually removed any particles as they've expired. So I'm going to add a little bit of code in my update here that basically says, as I'm going through and I'm updating them, I'm going to check to see if they need to be removed. So I'm going to say if the particle.age ever gets to be greater than particle.lifetime, then we want to remove those. And I'm going to do that the way we've done before. So I'm going to make a to be removed list here. So particles, actually, we need to make that list before this loop. So particles to remove list, we'll make that empty. And then we're going to append some things to that. We're going to append any of the particles that need to be removed. And then after we're done with that loop, we're going to go through the particles to remove list, and we're going to remove any of those from our main list. So self.particle list.remove. That particle. Okay, so this is all stuff that's similar to what we've done before. And just to test out our things that we made here, let's make a little bit of code here just to test this. So we're going to make we're actually going to make a particle list here. So I'm going to say particle system equal generic particle system. And now we're just going to use that. So I'm just going to have a couple keys here, and I'm going to say, or actually, let's not do keys. Let me do the mouse. So let's do if, let's get the mouse buttons first. So mouse left button, mouse middle button, mouse right button equal pygame.mouse.get pressed. And I'm going to say if mouse left button is pressed. So if the mouse left button is pressed, then I'm going to append a particle to that particle list. So I'm going to say particle system dot. And if you remember, what we had in that was emit particle, and we just pass it an X and a Y. So I'm going to do that. Emit particle. We're going to pass in an X and a Y for that. So the X and the Y for this, I'm going to use the mouse X and mouse Y, but I need to get those. So mouse X, mouse Y equal pygame.mouse.get position. So where am I going to emit the particle? At the mouse X and the mouse Y. Now, in my main code down here, I'm just going to do particle, oops, I don't know why caps lock got pressed. So particle system dot update particles and then render particles. And we probably made a mistake in there. We'll run this and see what happens. Okay, generic particle system is not defined. Let's go back and look at what do we call that. Particle system. All right, so we had a typo. Okay, well now it's actually up and running. And so now when I click the mouse, you notice there are particles being created. And so you can start to see how this is going to be kind of like our smoke trails going up. So if that was a rocket going up the screen, you can see how that would do that. Now, when thinking through the different kinds of things you need, the smoke trails, though, they need to be like a gray color instead of white. They need to get larger and more transparent as they exist. But you can kind of see how this generic particle system is now going to be modified. Now, one of the things, though, about the snow, when you create the snow, like how would I make snow out of something? Well, snow is going to be going in the downward direction. It also needs to last until it leaves the screen instead of be reclaimed when the lifetime expires. So the lifetime stuff is going to have to be a little bit different on that. Also, we don't want it to get larger or change colors. Let's go ahead and make these change colors as they age a little bit. But notice you could do that by essentially thinking about what the difference is between this generic particle system that we just created and what a different kind would be. So I'm going to go ahead and just make a snow particle system from this very quickly. And so I'm going to say class snow particle system. And I'm going to build this one using inheritance off of this generic particle system. Now, what things need to be different? Well, updating them could probably be very similar to what we have. Rendering them could be very similar to what we already have. But the one thing that, the couple things that might change would be how it gets emitted. It's still going to have a list, so that constructor can be the same. But let's just override how it gets emitted here. So I'm just going to take that, and I'm going to copy the emit particle for the snow particle system down here. And when we emit one of those, we don't want to have the direction be random. We want to have it be kind of in that downward direction. So that downward direction is going to be, well, 270 degrees. So I'm going to put it exactly at 270 and take out the randomness to it. So they're all going to be going straight down when they get started. If you wanted to make a range, have them be a little bit off, that's okay. And the start speed here, I can do that. The lifetime, we're going to make that work a little bit differently. But in order to do that, let's make the lifetime, or let's make the speed pretty much constant for the snow as well. Let's make the speed like 100 pixels per second in that downward direction. Now, one thing though, this start X and start Y for emitting that particle, that snow particle, well, I'm going to actually take those out because we don't need an X and a Y to emit the snow particle because we're going to set those inside of here. And what I'm going to do is I'm going to set the X and Y, so self, or actually I'm going to set those, here we'll just do it this way. We'll do start X equal and start Y equal. And we're going to actually fill this in. So the X is always going to be a random number along the top of the screen for the X. So here we're just going to do random dot randint. And let's do 0 to 799, so somewhere along the top. Where's the Y? Well, the Y is going to always be at 0. It's always going to be exactly at the top. So notice we're overriding some of the things that make that. And when I come down here and actually make the size, let's make these smaller. Let's make that 2 to make snow. And for the color, let's give it a little bit of transparency here. So it'll still be white, but we'll make this like 150, so it has a little bit of transparency to it. And now here, rather than making a generic particle, let's make this a snow particle. But we're gonna build that snow particle off the generic one, so it's gonna work pretty much the same way as what we had here. Okay, so we just overrode some of the things. We made it speed faster, changed the direction, started it somewhere else. And I'm gonna, before I make that snow particle type class, I'm gonna come down here and I'm gonna add a key to make snow. So I'm gonna say if keys pygame.k _ space. So if they press the space key, then we're going to do snow system dot emit. And since we overrode that, we no longer need an X and a Y for that. We're just going to say snow system dot emit when they press the space. And then down here, when we update these and render those, we're also going to do the snow. So we're just going to make this snow system. And I'm going to make this one snow system. So I'm going to update those and render those. Now, one other thing we need to do here, so that we updated the emit particle for the snow, let's actually update the snow particle itself. So that's going to be a lot like the generic particle, but the difference that we're going to have here is the constructor can all be the same, but we want to change how the lifetime works here. That we essentially, in this case, we don't care about having its lifetime, it go away when the lifetime expires, but notice that that's not really handled in here. So we don't really even need to update any of this. I'm just going to make a snow particle system built off of the existing one. I am, however, going to make one change to this, and that's that I'm not going to care about the age and drawing that or not. So I'm basically going to make a snow particle. So let's go ahead and add that. It's going to look a lot like this. Here, I'll just copy this whole thing for right now, and then we'll take out the stuff we don't want to override. So let's do the snow particle first. So this is going to be a snow particle. All the stuff in the constructor is the same, so I'm going to take it out. We don't need to override that. But in update, I'm going to change that. I'm going to take out this text check here. And really, the snow particles, I'm not even going to really have them age like this. So I'm going to take out that. Although we could leave it there. I guess it's not really hurting anything. We'll leave it there for now. The render is going to be the same, so we'll take it out. So notice we kind of now have the differences only in the update, that it is not caring about drawing it only when it is below the age of the lifetime of that particle. The other thing we need to do here is how do we reclaim them from this list? Well, we don't want to reclaim them from the list until they've left the screen. So what I'm going to do up here, and specifically just the Y of that, so that was in our update particles of the particle system. So I'm going to override that down here in the snow particle system, right there. And we don't care about the age for getting rid of them. What determines when we want to remove them? Well, when particle.y gets to be greater than 599, then we add them to the list to remove. And the rest of it's the same. All right, so let's try that. Let's see if we actually can, we may have made mistakes there, but we'll find out. Okay, so snow system, I did not make that yet. I need to make one of those. So snow system equal snow particle system. So to be clear, the mouse particle system still works, but now if I press the space bar, it crashes. Snow particle may take snow. Let me look at that error. We'll fix that, and this will be where we finish up today. Snow particle, take snow. Oh, I know what I did wrong. This needs to inherit from generic particle. All right, there we go. Okay, so these still work just fine. And now if I press the space bar, I get the snow coming down. Now there's one thing missing from the snow right now. If I let off the space bar, it'll stop. That'll reclaim those when they hit the bottom. And that is, remember the snow particles were supposed to have a little bit of randomness to them as they move down. And right now they do not. So how am I going to add that randomness to them? Well, which thing should that be? That should probably be in our update. So what I'm going to do here is with this dx, I'm going to go ahead and say self.x plus equal dx, but I'm also going to add a little bit of randomness to it. So right here I'm going to say dx plus equal, and let's do a little bit of randomness. Let's do a random dot uniform. Let's do like -2 to 2. So we're getting a random number in that kind of x direction, and then we're just adding it to dx, so it has a little bit of randomness to it. And let's run that again. And there's the space bar. And now you'll notice they're kind of wiggling around. That's probably a little bit too much how it is there. But that should give you an idea for what to do. So notice we can have those going at the same time. Here are these falling down. And at the same time those are falling down, I can, well, in theory, should be able to move the mouse around while that's happening. And I can get those to go. So you're going to kind of do the same thing, but you're going to come up with, what do I need to do to make it make the rockets work? What do I need to do to make the burst particles? And what you might do is get those working individually on their own first, and looking how you want them, and then tie it all together into one final game. But that should give you an idea of how to go about this lab and how to use inheritance. And we will go ahead and just one more time run that again. Oops, run that one more time. There's that. There's the snow. The snow looks a little bit out of control. And if we wanted to change that snow, make it better, maybe we do minus 0.5 to 0.5 on that. Let's see what that looks like. Okay, that looks a little nicer. They're kind of wiggling back and forth. Maybe still not as, it's a little bit jumpier than we would like, but you'll notice that the rockets still work. Okay, so I'll stop there. Let's go back to the slides for just a second and finish up. So that should give you an idea how to do that. If you think about those different types, what makes each one different? Snow starts in a different place. It doesn't start at an X and a Y. It drifts slowly toward the bottom. When it also, the lifetime works differently. When it hits the bottom, that's when it gets taken away. The rockets start somewhere along the bottom, kind of like the snow, but they head in the upward direction. And when they disappear, they need to get replaced by a burst. The rockets also leave behind smoke particles. So as the rockets are moving, you're going to add smoke particles to that. There's a number of ways you can do that. You can make each rocket have its own smoke particles, or the rocket in your main program, you could say for every rocket in the list, go through and add smoke particles where the rocket is. There's a couple ways you can figure out how to do that. I'll let you figure that out. And the burst particles are kind of like fireworks, which just in a lot of different directions. But think about what makes each unique. How are they different from each other? They're all particles, but what makes a snow particle different from a rocket? Different from a burst, different from smoke? And then how do they update differently? How are they drawn differently? How do they change their behavior over time differently as far as colors and sizes and things? So think through that, and that should help you. And well, we already wrote the code, so I went out of order a little bit on what I was going to do there. But that's it for today. Work on the labs, try to get this done. And next class, we're going to start on looking a little more at some trig for doing some cool effects kind of things. And then we're going to start digging into tile-based games, kind of like on the old NES or Terraria. We're going to dig into doing that, and we're going to do some file I/O for loading levels from files rather than having to change your code every time. We're going to look at organizing our code into modules and assets and how to load levels and stuff. So we're going to get into some really cool stuff coming up, but work on these labs today, get that stuff done. And that's all for today. Everybody stay safe.